Okay guys, so in this particular video, we are going to look at the entire deep learning project, how we are going to continue further with it. Okay, some additional deep learning concepts will also be introduced along with the project that you have to build. Once you have built the entire project, you have to build it up only in Collab. No other place would work. Okay, so you have to, because we'll be taking it up for submission. Once you have built the entire project in Collab, the link to the submission of the project is down in the description of the video as a Google form. As you're able to see, this is the Google form which you have to use to submit the project. You have to fill it up properly, as well as there is a Collab link right over here. So you have to submit the link of your Collab notebook where you have built the project. For example, if I am able to show you collab.research.com, let's take up an example for this particular Google Collab notebook right over here. So it is taking up a second to load, so give it a second right now. So once it has loaded up, just like in the video, you will be seeing you have to create the entire project. Once the entire project has been created, on the top right corner of this particular page, you're able to see this particular share button. Okay, so you have to click on this particular share button and then copy the link. Okay, so Command C, copy the link of this particular notebook itself. Once you have copied that, you have to go to the Google form down below and paste the link right over here to submit your project. Along with that, please make sure that you're using the exact same email address that you were using in your attendance forms as well. Okay, and for the LinkedIn post, it's not compulsory, but if you want to show off what you have built in this particular bootcamp on LinkedIn, you can definitely post it right over there and share a link of that as well right over here. Okay, so once this is over, that would be it. This would be our final class. We have tried to cover up everything from right over here. This class will be taken up by Sahil Rahman. He has previously worked with companies like HP and Porsche as a data analyst and InstaMojo as well. So he will be helping you guys out with data science as well as the project as well. So thank you so much, guys. Let's continue with the learning process. Thank you.
Perfect. Thank you so much for joining in on the last day of this boot camp. Today we are going to wrap up whatsoever you guys have studied. Okay. So for today, I'm going to take this boot camp for the last day. Okay. So since it's the last day, I'm going to tell you about the ANN. Okay. And I'm going to demonstrate a single project in front of you as well. And at the last, I'm going to give you a project to do by yourself. Okay. And I hope you guys already know the drill. In order to get the certificate, you need to submit 100% of attendance along with the project submission as well. Okay. So do you guys know what is a neuron? Have you guys studied about neurons so far? Yes or no? Yes. Perfect. Okay. Cool. Some are saying yes and some are saying no. That you guys have already studied about a neuron and it has been discussed in this boot camp. Okay. So we are going to continue from there only. Okay. Now, as we know, how exactly a neuron works, right? Okay, no. So let me explain you what is the concept of deep learning and how exactly we can achieve it. Okay. Now, what happened is that we have deep learning. Okay. So whenever we start with the journey of AI, right? So in AI, we have machine learning as well, and then we have the deep learning as well. Now the situation comes up that why do you need deep learning when you already have machine learning? Okay, when you already have machine learning, then why do we need deep learning? Now see, deep learning is more advanced concept of machine learning, guys. Okay, deep learning is more advanced concept of machine learning which has been discovered after machine learning. That means we will be using machine learning for decades, and then we realized in the early 2000 that machine learning is very concise. We cannot use it to develop more complex application, right? So that's why we have deep learning. Now the entire motive of deep learning is to replicate human brain. The entire motive of deep learning is to replicate human brain. Okay, how we think, what are with our thought process, and so on and so forth. So this deep learning entirely focus on human brain. Okay, are you guys getting this? Awesome. Cool. Now the thing is that how exactly human brain works, because why we need to replicate human brain, because there are a lot of complex stuff that cannot be achieved by machine learning. Because in machine learning you are giving a data, to a machine, and it will going to learn from that data and will going to respond, right? But all the models of machine learning are not able to take the responsibility to make decision. Okay, now let's suppose we have two scenarios. Let's take a scenario to understand the difference between deep learning and machine learning, right? So we have a teacher. Okay, we have a teacher and then we have a student. So what happened in real life scenario is that, suppose a teacher has taken an exam out of 100, okay, and the student has scored, let's suppose the student has scored approximately 39, right? And the passing percentage is 40%, or passing marks is 40%. So what happened is that rule says that anyone who achieve below 40 is fail, right? Anyone who achieve below 40, or the marks achieve anyone who achieve marks below 40 is fail. Yes or no? Yes or no? Okay, right? So what happened, you must have seen the real world scenario. It often happens that whenever you go to a teacher and ask them that please give me 1 marks, 2 marks, or grace marks, right? So they will going to provide you the grace marks, right? Which is absolutely against the rule, but we make decision. Our decision is absolutely uncertain. Our decision changes from situation to situation, right? Now if this thing has to be done by machine learning will be very strict. Because machine learning program has been trained to follow a set of rules, right? So if you go to a machine learning model, ask them that, hey, I am getting 39, I just want one more marks, for like a grace marks to pass on. Machine learning will not going to allow you to do that, because it is following a set of rules. And a decision never changes with the time situation, right? Whereas in deep learning, when we are trying to replicate a human brain, because human brain makes decision differently in different scenarios. Okay, the decision that human brain makes is absolutely different in different scenarios. That's why the birth of deep learning happened. Is it clear to everyone? Let me give you one more example so that you can easily understand it. Let's suppose let me draw a path. Okay, so excuse me for my drawing, I'm not an artist. Okay, perfect. So let's suppose this is a path and this is a intersection, and over here you are having your car. Okay, you are having your car, and let's suppose your workplace is here. Okay, now while moving, you see that there are two intersections. One is A, okay, and another one is B. Okay, now the scenario is that if you want to reach to your workplace, if you're going by this road A, it will going to cost you approximately 2 hours. Because the road take you to the village scenarios and hotels and so on and so forth. It will going to take you 2 hours to reach to your workplace. Okay, let's take the scenario B. Scenario B says that if you're going to take the road B, it will going to cost you 30 minutes. If you're going to go with road B, it will going to cost you 30 minutes. Now, if I ask you that which of the two road you will going to take to reach your workplace? Is it the first? No, it's the last class. Okay, it's the last class. So instead of Shaurya sir, I'm taking the session for the last class. Okay, perfect. So coming back to the question, which road will you gonna prefer to take, A or B, to reach to your workplace? Come on guys. B. Okay, anyone else? B, exactly, right? So most of you will going to prefer the road B, because the time that has been taken is very less, right? So now what will going to happen if this is a machine learning model? If this happens to a machine learning model always going to choose B. Machine learning model will always going to choose B, right? Now, as I mentioned that a human decision changes from situation to situation, right? Now if I ask you, same scenario, road A will going to cost you 2 hours, road B will going to cost you 30 minutes. Now the day is that you don't have much work, Okay, you don't have much work and you don't want to reach early to your workplace because you don't have much work to do and so on and so forth. So you have decided to do a detour. You have decided to do a detour, enjoy the road, enjoy the view and so on and so forth, right? Which road among the two will you wanna choose? Which road you will going to choose? Come on. A or B? Come on. A, exactly, right? Now see, the entire thing is same, entire scenario is same. A will going to lead us 2 hours, B is going to lead us 30 minutes, but the decision, the human decision has been changed from situation to situation. In the first situation, when he wants to reach early, he will going to take 30 minutes route. And the second situation, when he want to do a detour, when he want to enjoy or different excuses and all that, he will going to take the road A, right? It might happen that for the following day he hasn't done some work and he want to give excuse to their fellow members that there was a lot of traffic and all that, so he has chosen road A. So this is the thing that deep learning is more more inspired from. Deep learning says it how exactly a human brain make multiple decision in multiple situations, right? So now deep learning is all about to replicate, guys, okay, to replicate human brain. Always remember this thing. Deep learning is always about to replicate human brain. Okay, it is always about human brain. Okay, now how exactly our human brain will going to work out, right? Now what happen is, let's suppose this is our hand. Okay, this is our hand and this is our brain. Okay, now let's see how exactly the coordination is being carried out. Now we know that all the nerves has been connected to our brain in some form, and they provide signals. They provide signals to the brain. Okay, and then brain provide them it will going to give you a signal back that will going to tell you what, how and what to respond in a different situation. Okay, let's suppose this is a winter time, right? So you must have used some kind of heaters and all that at your home, right? Like suppose this is your heater. Okay, this is your heater and you are bringing your hand in front of this heater. Okay, now what happened is that in brain there's a calculation going on. In your brain, as soon as your hand is placed near the heater, your calculate in the brain a calculation is been going on, right? So a chart has been created. A chart has been created like this. Okay, now this line is a threshold value. This line is a threshold value. Okay, now your brain will going to calculate the heat. The brain will going to calculate the heat. So let's suppose it has been started from here, right? Now you have placed your hand in front of heater. Okay, as the time passes by, you can easily feel the strength of heat, or you can say the effect of heat will going to be get increase minute by minute, time by time. Yes or no? Yes or no? Getting this? Right? The more time you will going to place your hand in front of the heater, the amount of sensation that you will going to feel will be higher and it will going to increase minute by minute, time by time. Right or wrong? Getting this? Are you guys getting this? Yes or no? Come on. Come on, guys. Come on. Are you guys getting this? Yes or no? Right. Okay. So what happened is that as the time passes by, as the effect of heat is going to increase, automatically your brain creates a chart and it will going the amount, as soon as the effect will going to increase, the chart will going to decrease. It will going to get decrease. As soon as it hits the threshold value, your brain will going to give the signal. To your hand that now please remove your hand. Your brain will going to give the signal to your hand that now it's a time to remove your hand because you have reached to the threshold value. Because if you are placing your hand over here for more time, your hand can get burnt, right? This happens, yes or no? This happens, right? So in the same way, what happen is, whenever the communication is being drawn between all of your sensory organs. towards your brain. And this message, the postman who take all the message and deliver to the brain is known as neurons. Okay, it's neurons, guys. Okay, neurons is responsible to convey the message from your sensory organs to your brain, and then brain will going to process out that information and will going to return back the feedback with the help of neuron to your organs. Is this clear to everyone? Is this clear to everyone? How much time takes to remove your hand? I haven't calculated that yet. Okay, perfect. Is this clear to everyone? Yes or no? If you remember, if you must have heard about the greatest scientist known as the Albert Einstein, right? And you must have heard about the theory that when he died, scientist has stolen his brain and chopped it into several parts and tried to find out how it is different. Ever heard about that incident? Anyone? Yes or no? Right. Now what happened when when that particular scientist failed, he has transferred all the brain pieces to the further scientists so they can experiment on that. And what was the resultant? What was the result of that thing? The result was that number of neurons was more in is present more in the Einstein brain, if you remember, right? So neuron are the responsible people who tries to convey message from one point to another, right? So the entire scenario, entire deep learning is based on neurons. Entire deep learning is based on neuron. And now we are not talking about biological neuron, guys. Okay, we are not talking about biological neurons. So in biological, neurons look like this. If you must have studied biology during your school days, you can relate with this diagram. You must have seen like this diagram, right? This is a kind of neuron. We have axon, we have tail, and so on and so forth, right? So this is the purpose of neuron, that transfers from one point to another. It transfers all the messages. Is this clear? Is this clear, everyone? Yes or no? Please give me a confirmation, guys. Is this clear to everyone? Yes or no? Okay, perfect. Now in the deep learning there are a lot of models. Okay, in deep learning we have a lot of models. We have ANN, we have CNN, we have RNN, right? So since this is the last class, we are going to talk about ANN only. Okay, CNN, RNN are different models. CNN are for media's file. If you want to classify any image, right? So you can go with CNN. Like Google Lens use CNN. Okay, Tesla cars use CNN, right? RNN is recurrent neural network. Everything that has been related to text, okay, all the natural language processing. For an example, you have that application known as Google Translator, right? It uses RNN only. Okay, so RNN will be used by all that operation where we are dealing with some kind of text, right? Sentimental analysis or recommendation system and all that. So we are going to that has been included in RNN. But we are going to talk about ANN in this topic. Okay, in any other bootcamp, if it ever happens, we are going to talk about CNN and RNN as well in those bootcamps. So currently we are going to focus on ANN. The full form of ANN is artificial neural network. Artificial neural network, or sometimes people call this as neural nets as well. Okay, they both are same. Neural nets and artificial neural network are same on neural network. Now if you see over here, we have three words. One is the artificial, another is neural, and another is network. Okay, so what exactly does this term artificial mean, right? If you must have heard about moon, we call moon as a natural satellite, right? We have two satellites. One is a natural satellite and one is an artificial satellite, right? So what exactly that artificial word signifies in artificial satellite? Can anyone tell me that? What exactly the word artificial signifies in the term artificial satellite? Come on. Anyone? Let's see who will be the first person to answer this. Man-made, exactly, man-made, human-made, right? So the same way we are talking about artificial neural network means we have two neural networks. One is the natural neural network that has been present in human body. Okay, one is a natural neural network that is being present in the human body, and the artificial neural network that has been created by taking an inspiration of the natural neural network, right? So this is an artificial neural network, right? Now neural network, we have talked about neuron is one, right? Now we are talking about a network, right? So if you are from a BTech student, or if you are engineering student, or if you must have learn about computer during your school days, you must have seen this kind of graph. Like, if suppose I am having one computer over here, and over here I'm having one more computer, another computer over here, then I can easily connect these two computers with one computer. Or you must have heard about the concept of LAN, WAN, and so on and so forth. Yes or no? Local area network and all that. How they are creating a network, right? How they are creating a network, and we have different computers over here, different system over here, right? So this entirely be known as a network. Okay, when we say neural network, that means we are having a lot of neurons that will going to make a network out of it. Okay, so we will going to have neurons. We are going to have neurons. Suppose this is one neuron, this is another neuron, this is another neuron, and so on and so forth. We are going to have a lot of neurons, and they will going to create a network. Okay, now we're going to understand how exactly neural network works. How exactly a neural network works. How exactly neural network works. Okay, now in a neural network we have three layers. Okay, whenever we create a neural network, we always have three layers in this. We first have an input layer. Okay, we first have input layer. Second, we have hidden layer. Okay, second we have hidden layer, and third we have output layer. Third we have output layer. Okay, these are the three layers that will always be present in our deep learning model. Okay, input layer, hidden layer, and output layer. Okay, no other layer will be added over here. Okay, input layer will always be one, or the starting layer. Output layer will be the last layer, and it will always be one only, right? So this is the first layer, this is the last layer. Okay, this is the first layer through which the information will going to pass on to the next layer, right? Like, suppose if we have our hand over here, so hand is standing as the input layer over here, right? From which the message is been given, to the brain, right? Now brain will going to process out, and then will going to give you some kind of output over here. Okay, so we have input layer, we have output layer, and then we have hidden layers. Okay, hidden layers are the set of neurons, or you can say over here only the neural network will going to work out. Okay, so you can have many hidden layers. Okay, you can have many hidden layers, but one hidden layer is mandatory. Is this clear? I have to go very fast because I have to cover a lot of topics over here in ANN, right? So let's go on. Is this clear so far? Yes or no? Is this clear so far? Yes or no? Perfect. Okay, so we have input layer, we have output layer, and then we have hidden layer. Okay, so input layer is the layer from which you are going to pass the information to the hidden layer. Hidden layer are the layers where the operation and the computation will going to happen. Okay, hidden layer is the layer where all the computation will going to happen, and then it will going to give you the output that yes, this is the output. Okay, so suppose you are having a picture, you are giving a picture of a dog, right? And you say that, hey, predict this whether it's a dog or cat, right? So now it will going to go to the input layer will be connected to the hidden layer. You can have multiple hidden layer. Okay, and that hidden layer will going to perform all the computation, whether this image nose is looking like a dog nose, or whether eyes is looking like a dog eyes, and so on and so forth. And then it will going to give you an output, yes, it is a dog, or no, it is not a dog. Okay, let's talk about the neurons, how exactly neuron works. So let's suppose this is a neuron. Okay, so neuron has been divided into two parts. The left part is known as the submission part, and right part is known as the function part. function part. Okay, so this is the summation part and this is the function part. This summation will going to take lot of features. This summation will going to take lot of features from their previous layer. Okay, so let's suppose we are having one feature over here, another feature and another feature. Okay, let's suppose this feature is tail. This feature is tail. This feature, let's say eye, and then we have another feature known as, let's suppose, fur color. Okay, so now what will going to happen, that you need to give some input to a neuron. You need to give two things to a neuron. First, you need to give the feature. Second, the weight of that feature. Weight means that how much confident are you that this tail is being corresponded with that particular image that you are giving, right? So let's suppose this tail is x1. Let's remove this. This is a feature. Feature will be denoted by x1, sorry, x. Then we have x2, and then we have this x3. Okay, then we have x3 over here. Now you need to give another parameter that will be your weights. That will be your weights, that how much confident are you that this is the tail of dog, or this is the eye of that dog, this is the fur color of that dog. Okay, so you need to give the weight of, with respect to each feature. So let's write, this is your weight 3 and this is your weight 2. Okay, so summation part, what summation part will going to do, it will going to perform the submission of all this value. It will going to follow, you must have seen this equation, y is equals to mx plus c. Did anyone see this equation ever? Y is equals to mx plus c, yes or no? Straight line equation, sorry, linear line equation, yes or no? Okay, yes or no? Perfect. So similarly, we are going to follow this equation over here in the summation part. If you have not heard about linear regression, right, then you must be familiar about mx plus c, where m is your slope and c is your intercept, right? So in the summation part, this exact formula becomes y is equals to wx plus b. Okay, so where w is the weight, x is your feature, and b is a bias. Bias means it's a constant. Okay, so automatically the machine will going to select a constant value and we're going to put it over here. Okay, so we are going to provide the summation over here. So the entire formula will going to become y is equals to, first feature is x1 and then the weight. So it will be x1 into weight 1, then again x2 into weight 2, then again x3 into weight 3, and then at last you will going to add a bias. You will going to add a bias, right? So you will be calculating y from the submission part. You will be calculating the y from the submission part. When the submission part is being done, the y value will going to pass on to the function part. This function part is known as the activation function. Over here we use activation function. Activation. Okay, we are going to use the activation function over here, guys. Okay, now what is the activation function? This activation function will going to tell us that whether or not this is a dog or a cat, whether this is a dog or a cat, right? So the decision making has been happening in the activation function, right? So we have different kind of activation function. We have a sigmoid function, we have ReLU function, we have tanh function, and we have many more other functions, right? So let's talk about the sigmoid function. If you must have read about logistic regression, right? So we use the formula of sigmoid to decide whenever we are dealing with a binary classification problem. Okay, so you're going to choose a function from here, and then that function will going to decide what will going to be the output. That function will going to decide what will going to be the output, and then this portion will going to return you the output. Okay, if suppose it's a dog, then it will going to return 1. If it's a cat, it will going to return 0, and so on and so forth, how you're going to define. Okay, now there are other values as well that you need to make sure about. Is a loss function. Okay, then we have optimizer. Okay, loss and optimizer is very important. You need to understand about this, that whenever you are going to solve this kind of problem, so obviously you will not going to get 100% efficient, right? You will not going to get 100% efficiency over here, because whenever you train a model and you ask a model about a certain stuff, let's say you are bringing a dog photo, right? And you're asking a model that is it a dog or cat, your model will not going to say that I'm 100% sure that this is a dog, or I'm 100% sure this is a cat. Okay, it cannot be done, because achieving 100% of accuracy is absolutely a bit impossible, right? So it says 99% or something, or 88%, so on and so forth. So all the rest percentage that has been unoccupied is known as a loss. Okay, so more the loss, less will be the accuracy. More will be the loss, less will be the accuracy. Always remember this thing. More will be the loss, less will be the accuracy, and it's vice versa. Okay, there are inversely proportional to each other. Accuracy and loss are inversely proportional to each other. Okay, now we are going to use a loss function to find out that how much loss has been done, and we use this optimizer to minimize the loss. Okay, we are going to use a loss function to rectify to know that how much loss has been achieved, and then we are going to use the optimizer to minimize the loss. Is this clear? Is this clear? Yes or no? Is this clear, everyone? Yes or no? Okay. Yes or no? Please respond. Perfect. So this is really complicated stuff, right? It cannot be understood in just one session. I can easily understand it, right? But since we don't have that much time due to the time constraint, I have to wrap it. Okay, so let's go on and check a practical implementation. Let's create a project, simple project. Then this is theoretical. See, in machine learning and data science field, majority of the things are theoretical. Okay, because the implementation is a 5-minute work. Okay, so if you are in a data science field, so I would say it is approximately 60 to 80% of theoretical knowledge you have to gain, and other rest is a practical knowledge, right? Because a practical thing can easily be done with a snap of finger, right? Because we have a lot of libraries using Python, so we can do that. So you should need to have a theoretical knowledge rather than having the practical knowledge. Okay, in the field of data science that corresponds to your data analysis. It might be your deep learning, machine learning, big data, cloud. Okay, perfect. So let's see how we can create a project out of it. Okay, now let me connect this and increase the size. I think it's visible, right? So the first thing in a project you need to make sure is you need to import the respected library that you are going to choose. Okay, so we are going to create a section over here. I'm going to use importing the libraries. Okay, so I'm going to use all the libraries that I'm going to use. Okay, I'm going to use NumPy as NP. This NP is an alias. Okay, so this is just a naming convention, right? I'm going to use matplotlib.pyplot as plt. Okay, I'm going to use Seaborn as well, SNS. Okay, now the very important thing, the library that I'm going to use is TensorFlow. Okay, you might have heard about TensorFlow, or you might have seen somewhere about the TensorFlow, right? So what happened is that we have different libraries to perform or different tasks in deep learning. Okay, so the major libraries, let me write over here, libraries of deep learning, so you can have the reference. Libraries of deep learning. Okay, so you have Theano. It's not Thanos. Okay, please, it's not Thanos, it's Theano. Okay, it sounds like one, right? Second is Keras, and it's not Keras, it's Keras. Okay, then we have TensorFlow, we have PyTorch. These are some of the popular deep learning libraries. Okay, these are some of the popular deep learning libraries. Okay, so what happened is that earlier Keras was a company. Okay, they have introduced their deep learning models and all that, all the algorithms. Then what happened that when TensorFlow came into action, TensorFlow is from Google. So what happened, they made a deal, and now you can access no each of the item from TensorFlow. If you want to access each of the item of Keras, you can access that with the help of TensorFlow as well. Okay, so we are going to install TensorFlow. You can read the documentation over net as well. I'm going to import TensorFlow, and the alias for the TensorFlow we use as a TF. Okay, so let me import Keras as well. I'm going to import Keras as well from TensorFlow itself. TensorFlow, let me import from TensorFlow, import Keras. Okay, is this clear? Is this clear, everyone? Yes or no? Is this clear, everyone? Yes or no? Please give me a confirmation. Okay, now, okay, so let's talk about the next section. So the next section will be importing the data set. Importing the data set. So I'm going to take a data set from Keras library itself. Okay, so what happens, various libraries has a different section or different class of data set from which you can borrow some data set, right? So let's talk about Keras. So Keras has a lot of variety of data sets. Okay, so we are going to take one data set from Keras itself. So I'm going to say data is equals to Keras, because I am taking it from Keras, right? So in Keras we have a data set. So if I write over here data set and then dot, now which data set do I want? So these are all the data set that is been available. Okay, so if you're a beginner and you don't you're not getting a lot of data set in the market, you want to start with a simple one, you can start with these predefined data set for you. Okay, otherwise you can download it from Kaggle as well, as it will going to suits you. Okay, so today we are going to use this MNIST data set. Okay, so now what will going to happen, the data will going to applied over here. Okay, so the data will going to be applied over here. Okay, so let me show you how exactly it will going to look like. Perfect. So an instance has been created. An instance has been created into data objects. If I'm going to write data, it will going to show you the location. See, the address and the location will be shown up over here, right? But I want to see all the data, right? So first of all, I want to have to download it from Keras Hub. Okay, so wherever the Keras has imported all the data set, I have to import over here. So I'm going to use df, a variable where I'm going to say data dot load data. Okay, this load data will going to download the data set. Okay, and we're going to store it in df. Okay, let me run this. Now see, it is downloading two data set. It is downloading two data set. One is your training data set and another is your testing data set, guys. Okay, it is downloading two data set. One is your training and another is the testing data set, right? So what I'm going to do is, if I print df over here, see this. So these are all the data set of an images. Okay, always remember this thing, that image is been created with pixels, right? We have pixels in images. Each pixel values range from 0 to 255. Okay, it cannot be greater than 255 or it cannot be lesser than 0. Okay, now over here, if you see that we have converted all the image into the matrix form, into a matrix form, right? Wherever there is no color, we are getting 0. Wherever there is a slight in shade of a color, you will be getting all the values, right? But these value cannot be exceed from 255. Okay, the range of this value will be between 0 to 255 only. Okay, now since we have two data set that has been got into df, that is your training set and testing set, I'm going to split the data set. I'm going to split the data set. So I'm going to create a df. So I'm over here, I'm going to store training data set, that is your training data set, and y train. Over here I'm going to store our testing data set, y underscore test. Okay, so what will going to happen, the training data set will going to come up over here, the testing data set will going to come up over here, and training data set will going to have x train, that is your feature, y train will going to contain your output or target value, right? Similarly over here in the text in the test part as well. Okay, let's run this. Now let's check x underscore train. Okay, dot shape. Can anyone tell me what does this shape function will going to do? Can anyone tell me what does this shape function will going to do? Anyone? Anyone? What does this shape function will going to do? Anyone? Come on. If you have read about NumPy, right? If you have read about NumPy, it will be easier for you to tell me that why we use shape function and what shape function will going to do. Anyone? No one? Okay, so shape function will going to tell me how many number of rows are there, how many number of columns are there, how many total number of no matrix is been present. Okay, so over here if I'm going to run this, it will going to say there are 60,000 images. Okay, and each image is having the resolution of 28 by 20. That means the shape and the size. Okay, over here the rows, right? So suppose if we have a pixel, sorry, if we have an image is been created of various pixel, right? So it says 28 by 20, it means that 28 pixels in a single row and 28 pixel in a single column. Okay, 28 pixel in a single row, 28 pixel in a single column. Okay, and 60,000 images are been given for training data set. Okay, let's check for the testing data set how many data are being given for the testing data set. So 10,000 data set is been given, right? 10,000 data point is been given for the testing purpose. So in total we have 70,000 of data points. In total we have 70,000 of data points, right? So let's check one image. Let's check a single image. X underscore train 0. Okay, so if you see, this is a single image. This is a single image. Wherever there is 0, that means it's a you can call this as a darken area. You can call this as a darken area as well, right? And wherever there is some value, if you see some value over here, this value, so here something has been written or something has been shown, right? Now if you want to see some image, if you want to see this image, this is a pixel value image, right? I want to see what exactly is the actual image over here. So you can use matplotlib. Okay, so I'm going to use this function plt dot mat show, and I'm going to write x underscore train 0 to show me the image. Kindly show me the image. Now the image is this. This is the image. Okay, can you see this darken area? Wherever there is darken, it has been reflected by 0, and whenever there is some kind of shade, okay, whenever there is some kind of shade, according to that the pixel value will be appear over here, but no pixel value can exceed 255 or the range of 255. Is this clear? Is this clear to everyone? Yes or no? Come on. Okay. Okay, yes or no? Okay, perfect. So if you want to print some more data points, you can print that as well. You can loop this out. Okay, so if I'm going to loop this out, let's see. So I'm going to say for I in range 10, and instead of the 0, I'm going to replace it with I. Okay, so what will going to happen? It will going to print me the top 10 images, right? So if you see, these are the top 10 images. So over here the data set is all about the number data set. So we are having a lot of images. Each image contain a number from 0 to 9. Okay, now we are going to give some image, and then our model will going to classify which image is there. Is it 1, is it 2, is it 3, is it 4, so on and so forth. Is this clear to everyone? Yes or no? Okay, now the next process is to flatten the matrix. That means convert the matrix into one dimensional. Okay, if you have heard about NumPy, you must have been known about the dimensions. Okay, now we are going to flatten our matrix to convert it into a single dimension, guys. Okay, we are going to convert this to convert this into a single dimension. Okay, so now let's come up over here. Let me show you for the testing part. Y underscore test dot shape. If I'm going to run this, it will going to say I'm having 10,000 values. That means it is the series. It's a series part, right? So even though if I print y_test, you will going to see it's a series, right? We have a single array and the dimension over here is one dimension. See, endim, it's one dimension, right? But if I print x_test endim, okay, it will going to say that it's a 3-dimensional, right? It's a 3-dimensional. We don't want 3D. We don't want 3D, right? So we are going to convert this. We are going to flatten the matrix. Flatten the matrix means that you are reshaping your matrix, or you're converting your matrix to your one-dimensional, right? So I'm going to say y_train, okay, _flat. So over here I'm going to store my flattened matrix. So I'm going to say x_train. I'm going to reshape. Okay. So I'm going to reshape from length of x_train into 28 cross 28. 28 cross 28. Okay. This length means if you have if you are familiar with NumPy, then you can easily use the function reshape. I want to convert this in such a way that this will be the length, okay, or if you don't know the length, instead you can use -1 as well. So it automatically detects the length of the array, and then 28 by 28, okay, that means 28 by 28, it will going to have the multiplication of the entire pixels, okay. So now let me copy this again and paste it over here, because we have to have for the test value as well, right? So test value, okay. Now I'm going to run this. Now let's check whether the dimension has been changed or not. So this is for the entire part, right? So we need to check for the images. It is 2-dimensional, right? So now let's check what will going to be the dimension. Endim. Perfect. Now if we see, we are having 1-dimensional over here, right? So now everything has been converted into 1-dimensional, and now we are good to go with the model creation, okay. Now let's start with ANN model creation. So let's do this. ANN model creation. Okay, so now we are going to see how we can create a artificial neural network. So for that, I need to have some stuffs. So I'm going to use TensorFlow, and in this TensorFlow, I'm going to use Keras, and I'm going to import sequential. Okay, this sequential will going to help me out to create the layers. Okay, this sequential will going to help me out to create the layers. Oh, this is not flow, this is flow, TensorFlow. Okay, next I'm going to use TensorFlow.keras only and .layers. Okay, and I'm going to import dense layer. I'm going to import a dense layer. Perfect. Now this what is this? Cannot import the dense from the TensorFlow Keras. Not an issue. Let's import this from Keras itself. From Keras.layers. Import dense. Okay, not the, it should be dense. Okay, and TensorFlow dot. Now it should work. Perfect. Okay, now this sequential will going to contain all the layers, okay, and this dense will going to help us to create multiple hidden layers. Okay, this dense will going to help us to create multiple hidden layers, and the sequential will going to help us to store all the multiple layers. Okay, now we're going to start with model. Okay, this model is the object, this model is the instance of our model. Okay, I'm going to start the bucket using this sequential. Now in this sequential, I am going to contain multiple hidden layer. Okay, so the first hidden layer will be dense, second and third and so on and so forth. So I'm going to use list data structure. Now let's add the first hidden layer, dense. Okay, now it will going to ask you the unit. Unit means the number of neurons that you want to have in the first hidden layer. So I'm going to say I want only 10 neurons in the first hidden layer. Second, the input size, because the you need to make sure that the first hidden layer should be connected with the input layer, right? So I need to give the input shape as well, that what exactly is the shape of the image, right? Now the shape of the image is 28 into 28, that is 784. Yes or no? Right? How I know that it is 784? Let me show you. If suppose this is your xtrain dot, sorry, not dot, 0 dot shape. If you check the shape, you will be getting 28 into 28. Not the xtrain, sorry. This is should be xtrain flat. Okay, it will be 784, right? With the help of this 784, I already know the input size will be 784, right? Now I need to provide an activation function, which I have already told you, which will going to help us to make a decision. So activation is over here, will be sigmoid. Okay, we are going to use sigmoid function. All the documentation is being given to Keras documentation panel and TensorFlow Keras documentation panel. You can kindly refer to that, okay, for more information. Now I want that while this model is going to train, if any loss will going to occur, I am going to define an optimizer, so that even though if a loss will going to occur, optimizer will going to help us in each epoch to lower the loss. So we know that if loss will be lower, the accuracy will be high, right? So we are going to use model dot compile function. Okay, in this compile, I am going to give a parameter known as optimizer. Okay, and I'm going to use the optimizer name as Adam. So we have a lot of optimizer. You can search it on the Keras website or documentation itself. Okay, I'm going to use a loss, which will going to tell me that how much loss has been created. So which function I'm going to use? I'm going to use sparse categorical cross entropy. So I'm going to use sparse categorical cross entropy. Okay, and last is your matrix. Last is your matrix for your accuracy, right? If you have done machine learning, then you might have known that there are different matrix to find the accuracy, right? We have R square, we have RMS, we have RAE, we have confusion matrix and all that, right? So if I want to get the accuracy, so which matrix, according to which matrix do you want me to show the accuracy? So I'm going to use the accuracy. I'm going to use the accuracy, right? There might be some confusion matrix and so on and so forth. You can refer to that. So now I'm going to run this. Perfect. Now we are going to start with the training our model. Now we are going to start with training our model. Train or fit. Okay, training or fit the model. Okay, so now I'm going to say model.fit. Okay, now I have to give the data over here, xtrain underscore flat and y underscore train. Okay, I need to give another parameter known as epochs. Okay, epochs means that how many times do you want your model to see the data, right? Now we know that more the time, just understand in this way, epochs means that that more you are going to study, more you are going to thorough with that concept, more better you can explain it, or more better you can get marks, right? Like suppose your teacher told you that in the upcoming weekend I will be taking a test on the topic magnetism, let's suppose, right? You have given a read to magnetism. Now does that mean that you have understood everything? Does that mean you have got all the knowledge of the chapter magnetism by looking it at once or by reading it? Yes or no? Tell me. Yes or no? Come on, come on, come on. Tell me, guys. Your teacher told you that in the upcoming weekend I will be taking a test on magnetism chapter, which you have never ever seen, right? Now you have started to learn about magnetism, right? On the first go you have looked everything and you have ended up, right? Can I say that on the first go only I have understood and have acquired 100% of knowledge? No, right? Now on the second go, when you are going to go through the chapter, your confidence will be more, right? Now it will be an ongoing process. The more you will going to read the chapter over and over again, the more better you understand that chapter, or more better you understand the equation, and you can solve any kind of problem, right? Similarly is the epoch. Epoch says that how many times do you want your model to see the data. The more the time the model will going to see the data, the more better it will going to be trained. If suppose this data is the differential data, right, where you have to differentiate whether the image is containing the no digit 0, 1, 2, 3 and so on and so forth, the more your model will going to see the data, the more better it will going to differentiate between the different features, that this is 0, this is 1 and so on and so forth, right? So you can say that even the epochs also plays a very vital role in the accuracy. More the epochs, higher will be the accuracy. Okay, more the epochs or higher will be the accuracy, right? But not at the extreme level. You cannot go with 1000 epochs, 1000 epochs to acquire 90% or 98%. No, right? At a certain point your epochs will going to start decrease or will going to maintain the consistency, right? Let's say, to save the time, let's say we are going to go with 10 epochs. Okay, now when I'm going to run this, we will be able to see all the details on the first epoch, what was the accuracy, what was the loss and so on and so forth. You guys have to notice that as soon as the loss will going to decrease, automatically accuracy will going to increase. Okay, so shall we start with the training purpose? Yes or no? Okay, come on guys, tell me. Shall we start with the training purpose? Perfect. Awesome. Let's start this and keep your eye on the output, please. Now see, this is the first epoch, this is the loss and this is accuracy. First epoch is done. Now second epoch. Then we have the third epoch. See, fourth epoch is to be done. And if you see, loss is been decreasing, and because we have used the optimizer, okay, and accuracy is been increasing, right? So if you see, they are you can say intercorrelated, okay, or inversely proportional to each other. Now the last epoch is been left and done. Okay, so now if you see, in the last epoch we have achieved the loss 5.23 and accuracy is 89. That means 89%, our model is 89% confident that if you are going to give any kind of image, it will going to tell you that it is a 0, 1 or so on and so forth, and it is 89% confident. If you see, from starting we have achieved approximately 84%, and after the epoch, as the epoch has increased, we have achieved 89. That means 5% gain. 5% gain in the accuracy that result in the loss function. Is this clear? Right? So now our model is being trained. Now what we have to do? We have to test our model. Yes or no? We need to test our model. So we are going to test our model over here. Okay, I'm going to say y_predict. All the predicted value will be stored into the y_predict. So I'm going to say model.predict. What we are going to predict? We are going to predict x_test_flat. Yes or no? So let's run this. So model has been predicting. So now model has been done with the prediction. So let's say y_pred. Let's run this. Perfect. So these are all the values that model has predicted. For the first image, it will be 4.9. That means if you are going to round this up, it will be 5. For the second image, it is 0, so on and so forth. Now we are going to evaluate the matrix. To test out how much efficient this is. Right? So now if I say y_test. Okay, so if you see over here, this is your y_test and this is your predicted value. of x_test_flat, right? So you can easily compare how much they have, how our model has performed. Okay, how our model has performed. Even though if you want to evaluate your model, you can evaluate your model as well. Model.evaluate. Okay, over here you are going to give x_test_flat. flat, and then you will going to give your y test as well, right? Now it will going to evaluate this and it will going to tell you that if this is your data, then you will be achieving 89% of accuracy with 6.6% of loss. Is this clear to everyone? Is this clear to everyone? Yes or no? Okay. Yes or no? Perfect. So now this is a simple ANN that we have created, and over here we have used only a single hidden layer. That means this is your first hidden layer. Okay, if you want to go forward, you can create multiple hidden layer as well. Suppose now you want to create another hidden layer. So what you can do is just copy this and paste it over here. This is your second hidden layer. Okay, and you need to make sure for the second hidden layer you don't need to give input shape for any other layer. Okay, only the first layer should be connected with the input. All the other layers should not be connected with the input, right? So you don't need to give the input layer over here. And number of neuron is totally dependent upon you. You can go with 20, 100, whatsoever. It's totally dependent upon you, right? So this is the entire session about ANN, how you can create your model and so on and so forth. Okay, let's come to the project part that you need to do and submit, okay, in order to get the certification. So let's see. Perfect. So let me provide the Jamboard link first. Perfect. So the Jamboard link is here, and this is your dataset link. Okay, so we have used MNIST from Keras. I want you to use Cypher 10. I want to use Cypher 10. Okay, I want you guys to use Cypher 10, and please don't try to copy from here, right? It should be unique, it should be genuine. Use Cypher 10, okay, to evaluate your model, and your model should be going to give you a higher accuracy or more better accuracy. Okay, is this clear everyone? Yes or no? Are you guys cleared about the project? Okay, so you need to do the project. You are having a 1 week time, and how you have to submit, click on the share button. And while sharing your project, you need to make sure that instead of this restricted, if you are submitting your file link, having this option be restricted, we cannot able to check your work. So kindly change this from restricted to anyone with the link. Okay, when it is done, then copy the link and provide over here where it is written submit notebook. So provide the link over here. Is this clear everyone? Is this clear everyone? Yes or no? Okay, perfect. And that's all for this entire bootcamp. See you guys in the next one. Kindly do the project. You have a week time to do all the part. Jamboard link has also been provided, so kindly refer to this. Is it clear to everyone? Yes or no? Is this clear to everyone? Yes or no? Perfect. So thank you so much for joining in. Enjoy your time. Have a great time and good night. See you all in the next bootcamp session. Thank you so much.